Hello and welcome to Not a Buffalo, the show where we discuss the science and technology that will save the world. My name's Ben, and I am so grateful that I'm an introverted video game enthusiast right now. This is Jack, and he always has a silver lining, mainly because of his expensive tailoring. Jack, how are you?
That is the most expensive form of tailoring, isn't it? Is to have actual silver in your jacket.
Yes, I think gold would be a bit gaudy, so silver really is the most expensive one that a good tailor will actually consider doing.
Yeah, platinum is just too base, isn't it?
Yeah.
It's not base. It's not a base metal at all.
Science jokes.
Yeah. No, I suppose it's a good time to do a shout out to everyone who's like us, talking to all their friends remotely.
Have you found the new global situation? I actually did a hangout with some friends on Friday, and we're all sitting around drinking wine from our living rooms. It's actually very comfortable and very pleasant. It worked pretty well.
Yeah, I mean, yeah, I've really been enjoying it. I've really been enjoying hanging out with people online.
And I'm finding I'm speaking to people more and like offering to do hangouts and wanting to do actual phone calls with them, where normally I just send them, the odd Facebook or WhatsApp message. And it's been quite nice. It's almost reconnecting people. I find a little bit like I've got some friends who I'd never really spoken to very much since I left the UK, and just gotten back in touch with quite a few of them, which has been quite nice.
Yeah, I've had a little bit of that. I've had a lot of friends reaching out to me from like countries which are far away. Like one of my friends from Taiwan got into contact today, which is really nice. So it's good to hear from him.
Oh, that's great. Yeah, it's, as we said, silver linings.
Yeah.
So, what's your first science story? I think this is a very good time to have a podcast where we both work from home. Or we can both do it from the comfort of our own homes, completely remotely anyway. But also where we can bring some good news to a world that seems to have lost its mind a little bit.
Yeah, perhaps in an attempt to play devil's advocate to that, my first story is about bees being undertakers.
Undertakers as in wrestlers or as in actual undertakers?
As in actual undertakers, although I think the BWWE is a thing that would kind of take off. No pun intended.
Okay, what's the word? We'll copyright or we'll patent that idea and discuss it later. But what's your story about bees being undertakers?
Yeah, so we've known this for a while, that bees could find their comrades in the dark, even when they're dead. So there's this special subdivision of worker bee which goes out and they track down dead bees and bring them back to the hive and that kind of thing. So this subdivision of bees can just recognize dead bees, and they can do it in the dark, they can do it at a distance, they can do it without seeing them. So the assumption has been for a while that it's been some sort of non-visual process or not entirely visual process. So maybe it's a smell thing, or it's a chemical thing, or it's a movement-based thing, or whatever. But this paper does cover the chemical side of it. So bees excrete pheromones from their antennae, and they use to identify each other and to identify, is this a friendly bee? Is this a bee from another hive? That kind of thing. And this researcher theorized that as the bee's body cools, then less of this pheromone will be let off. And so to do an experiment, he took dead bees and placed them in a heated petri dish so that the bee's body remained at the same level of warmth as it would when it was alive. And so it continued to give off those pheromones, at least for a little bit longer, or at a similar level to when it would have been alive. And the bees didn't notice that it was dead. Usually they noticed within about 30 minutes. It took them several hours to notice that this bee was dead, even though it was right in the middle of the hive. And it seems like there may be other things at play there, because they did eventually notice it, but
you'd hope they still have other senses like sight and hearing and everything, and would eventually notice and smell, and would eventually notice there was something dead in the middle of their hive.
You would, wouldn't you? So they did eventually notice it, but it's much slower when they don't have that heat difference in the bee. So there's more research that's needed to really understand exactly what they call death recognition process is. But this seems to be a good basis for it, and a good sort of starting point for understanding exactly how bees recognize the dead.
Wow, that's really cool. That's really interesting.
Yeah, there's a bit of research that came out of China, and the actual chemical is, what are they called? Cuticular hydrocarbons.
Cuticular hydrocarbons, okay.
Yeah, this is really just a sciencey term for the particular chemical that they give off. But yeah, it's a really interesting little study.
Yeah, I like that one. We always like bees on Not a Buffalo. We've brought them up a few times. We're big
Yeah.
fans of bees.
Yeah, you got to understand bees. Got to love bees.
Definitely. Yeah, I actually have a story about some insects as well.
Nice.
Did you ever play the computer game, or have you heard of the computer game The Last of Us?
I have heard of it, yeah.
About basically the fungus that turns people into zombies.
Yeah, because it's based on the fungus that turns ants into zombies, isn't it?
For our listeners who haven't heard of this, there's a type of fungus called a cordyceps fungus that can infect. There's a number of different strains of it that can, and they infect caterpillars and they infect ants. And they were actually talked about by David Attenborough in one of his Planet Earth series. But they infect. The spores infect an ant and then force the ant to climb a tree, and then the fungus can spore from there and disperse its spores across a wide area. So they've been kind of likened to a zombie fungus. They're called. Luckily, that doesn't affect humans yet. It's still in the world of science fiction.
I love how optimistic you are.
Okay, no, I will say this is an optimistic story. I realize I've set this up really badly, but what they found is that actually the cordyceps fungus has a molecule called cordycepin, and it switches on a cellular protein called AMPK, and what AMPK can do is help reverse some types of diabetes and cancer, and also protect against arterial and heart disease. Because what it seems to do is that when a cell has cordycepin, it converts it into a chemical called CMP, which is another chemical that the body produces naturally which also switches on this AMPK. But basically, it makes the cells think that they are running out of energy, even though they're not. So the cells start to work harder and can help tackle some of these health problems. It's an interesting avenue of research to provide more medicines. At the moment, as you can imagine, with it being a deadly fungus at the moment, they're being very careful with it.
Yeah.
It's not easy. You can't just extract the cordycepin and use it to switch on AMPK, because I think you have to get the balance exactly right, because if you have a bit too much, then it can be toxic, as is true of a lot of medicines and things. So they're working on it. But yeah, it just I thought it was really interesting that this kind of zombie fungus could actually help provide some new cancer treatments or diabetes treatments or just kind of general health benefits as well. So definitely an interesting avenue of study for them.
Does it just speed up cellular regeneration then?
Yeah, it seems to make the cells think that they are running out of energy, so that they start to work harder. They try and retain more energy or get more energy. So helping with their regeneration and increasing cell growth and things like that as well.
That's really interesting. It's also very much, it fits with the idea of a zombie disease as well, doesn't it?
It does, yeah, because they tend to be hard to kill unless you shoot them in the head.
Yeah, I really hope that's not something that becomes like standard advice during this coronavirus outbreak. I really hope that's not where the world is going.
I don't think so.
Nah, me neither. I'm sure we're fine.
The chance the coronavirus mutating into a kind of zombie illness would be... I'd definitely take the conspiracy theories about the CIA releasing this much more seriously if that suddenly happened.
I hadn't heard that. I didn't know there were conspiracy theories already. What's it been, like 2 months?
There's so many. Some people think that the CIA released it in China. Some people think the Chinese were developing it and accidentally leaked it. The main thing that people are pointing out, though, is that it's affecting the entire world's economy, including China's majorly. So it's quite unlikely that they were doing that. But also, if they were going to make a kind of bioweapon like that, they'd probably have made it a lot deadlier than it actually is. So it almost certainly isn't one of those kind of things. But yeah, there's been tons of conspiracy theories as well. I have a friend whose conspiracy theory is that China released it in order to have an excuse to trap people inside so that they could start increasing their birth rate under the one-child policy.
And they've just lifted that, haven't they?
They have, yeah. So some people think they were trying to increase the birth rate, and some people think that it's a kind of coordinated effort. They wanted it to happen in the USA and in Europe as well, so they specifically wanted it to spread to those because they want the same effect there.
It feels like a lot of work to get that effect, doesn't it? It feels like a very Heath Robinson kind of approach to population growth.
I mean, conspiracy theories aren't really known for thinking through all the logical consequences of their theories.
Is this what you usually tell to your friends when they give you conspiracy theories?
Well, I love. I am a big fan of a conspiracy theory podcast. I do love hearing the ideas. The only ones that really annoy me are the ones like the flat Earth theory, where I don't care if people do believe that. like that doesn't affect, when people think, oh, when you have negative conspiracy theories like a certain religious group is trying to take over the world or something like that, and that's bad, and I think those should be stopped dead. But flat Earth, I just wish they'd stop reporting on it, because I don't care if people don't know what size the world is or what shape the world is. As long as they're not trying to build a bomb to, I don't know, break the world in half or something, then I don't really care if they have a silly belief like that.
Yeah, same. I love listening to conspiracy theory and reading them, but I don't generally believe them. I sort of see it as inoculation. Like reading them for fun is a very effective way of being aware of them so they don't catch you.
Conspiracy theories allow you to kind of, when you hear a lot of conspiracy theories, especially the ones that are kind of, you can see them making sense, even if they're very unlikely.
Yeah.
And it kind of makes you go, okay, so what the actual, you kind of rethink about the actual situation and why that makes the most sense. And I quite like that sort of critical thinking that it can. I like to use it to try and trigger my critical thinking.
Yeah, I think it's very effective to do that.
So yeah, tip for all the listeners out there: read conspiracy theories. They're both interesting and can help you think about things more deeply.
Yeah, you heard it here first on this science podcast, that conspiracy theories are important, and a daily intake is vital to your survival in this time of self-quarantine.
And just to reiterate, to anyone who's half listening and just picked up on the actual conspiracy theories without listening to us say we don't think they're true, the conspiracy theories about the CIA and coronavirus and all of those are definitely not true. We are not advocating those in any way. We do not believe in them. I think it is just a virus that has happened to spread. It's a pandemic that's been predicted by hundreds of scientists for decades. We always knew something like this was coming. We just wish we'd been a little bit more prepared, but it is not a conspiracy theory.
In general, I think the world is coping pretty well with it.
It could definitely have been a lot worse, I'd say. The reaction seems to have been pretty quick to me, and pretty I know a lot of people were praising our Prime Minister here, and I know it has highlighted a lot of really good leaders, and a lot of people coming together as well. Yeah,
that's been really nice, hasn't it?
And like we said earlier, reaching out and reconnecting with friends and things. So I think I agree. We do seem to be dealing with it quite well.
What I really like just generally is it just goes to show that when humanity really puts its mind to something collectively, there is nothing that we can't do as a species. Like, the only problems we really have are those where humanity disagrees amongst itself over what it wants.
Yeah, and it shows, there's been Chinese scientists coming over to Europe and they've been sending face masks and things. And, I remember reading in the news in January and December and last year just about how, the tensions with China and disagreements with them. And then as soon as a situation like this comes up, it's like, no, we'll help you out, regardless of what's been going on.
Yeah.
And it is just bringing...
It's nice.
We know we can work together when we want to. And if only we could just keep that that attitude up.
Yeah. Speaking of coming together, do you know about a thing called the cosmic web, Ben?
I don't, but were you just keeping that conversation going until you could find a segue?
No, there were a few points where I thought I could segue into this story, because it's a story about slime molds helping scientists to map the cosmic web.
Ooh, that sounds really interesting.
Yeah. This one came to me this week. So let's start off with the cosmic web. When you look up at the night sky, you can see stars, right? Now, those stars exist within a galaxy, in our case, the Milky Way. And if you were to zoom out again, the galaxies would also show patterns.
Yes.
And there are big clusters of them, and there are trails of galaxies between these clusters, in some cases, and big flat walls of galaxies that we can see in the night sky. And all these structures go together to make something that looks very web-like, and so cosmologists call it the cosmic web.
Okay.
Now, it's a sort of large-scale structure, essentially, but it looks very random, and cosmologists generally don't like randomness. So that's the cosmic web. So the slime molds now. Do you know what a slime mold is?
Yes, I've heard of them before, but just explain for the listeners what they are.
Yeah, so they're this sort of slightly stringy yellowish substance. You often see them on dead trees. On the stumps of dead trees, and tracing between two different things that can give them nutrients. and they also have this kind of stringy structure. Now, what the scientists studying them have done, I think purely out of curiosity from reading the article, is they put together a simulation which predicts slime mold growths. And they tried this on lots of slime molds and lots of data, and I think they used some kind of machine learning to build it. But the simulation works very effectively. And then they tried it out on where the big clusters are in the universe of galaxies. And it predicts incredibly accurately where the connections between these clusters are.
Wow.
There isn't any sort of concrete reason why this should be, but it's probably just that the underlying physics are very similar. I think it's kind of cool that this data-driven simulation is able to predict something that is a one-off, because the universe isn't big enough for more than one cosmic web.
No, that is really cool. I love the idea of what's it called? The golden ratio appears in all aspects of nature. It's like these certain just patterns that seem to replicate in so many different areas of life, but having from a tiny slime mold to the cosmic web, and the link between the two is that's amazing. That's so cool to think about.
So the reason they were doing this was because the web is so thin on the cosmic scale. So, you've got lots of empty space either side, and then you've got a tiny string of matter going between two different bits. And so they were struggling to map it properly. And using the slime mold, it sort of predicts where there will be galaxies and where there will be matter. And they're using that to sort of act as a guide. And then they check where it is, and it goes, oh yeah, there is matter there, and it's that kind of thing. And I think it's a great sort of cross-disciplinary piece of science.
That is, yeah, I really like that.
Do you have a segue for us? I feel like you do.
I don't really have a good segue, actually. I'm just trying to think.
My God, I think this is a first for Not a Buffalo.
I know. I suppose. Okay, so from slime molds to seahorses. Are you familiar? You're familiar with seahorses, Jack? What do you think of seahorses?
I think it's a good thing they're alliterative with slime mold.
Yeah, that's the best I could come up with in terms of a segue.
Yeah, that's fair enough. I know there's something about the males of the species carry the babies.
That's true.
But I don't really know anything else about seahorses.
Well, seahorses, unfortunately, a lot of the species are endangered. A lot of them are hunted because they're used in traditional Chinese medicine, or harvested for traditional Chinese medicine.
Oh.
And then there are also their habitats, such as seagrasses and mangroves, are being destroyed, being captured in fish trawling nets and everything. And so some scientists in Australia wanted to try and help this. So they started building them what they describe as little 5-star hotels.
That is kind of sweet.
It's really nice. Yeah, so they've realised that a lot of old abandoned lobster traps and things like that is when they're left in the ocean, especially around Australia, things like coral and sea life kind of gets attracted to it, because especially for seahorses, they often have to use their tails to hang on to things because the currents are quite strong and they can't swim that strongly because they are only really small. The example they give here is a white seahorse, which only grows to about 16 centimetres long. And it needs kind of to live among sponges and soft corals and seagrasses and things like that. And so scientists, they've been creating these hotels for them. The article unfortunately doesn't go into much of a description about the hotels, but actually they put them in and they were meant to be a kind of temporary habitat whilst the now protected natural habitats kind of regrow over time. And they found that the seahorses really like them. They deployed. It only took 2 months for seahorses to start using them, and they realized throughout 2018 that they kept coming back and using them, and that they've even been able to start mating in them. And as you said, the seahorses, it's the males who carry the babies in a lot of those. When they saw the breeding season begin in October 2018, they found that 13 males living in the hotels have become pregnant.
That's fantastic.
And they want to start trialing the hotels in Gibraltar, Greece, the United States, Philippines, and Indonesia as well. And it could be a really nice way of saving the seahorses. And it's just kind of they sort of stumbled across the idea. Ooh. Yeah, there is a little video which I'll try and remember to share, because you just kind of see the seahorses kind of darting in and out between the corals and between these little seahorse these little hotels, and it just looks very it looks kind of Disney-esque. It's very sweet.
Oh yeah, we should totally share that on Twitter. That's really cool.
Actually, just as an addendum to that as well, it's not really a full science story, but kind of tagging onto that is they did a survey of Africa's black rhino population, and they found that they've had an annual growth rate in their population of 2.5%. So it looks like they're on the road to recovery. Still endangered, but on the road to recovery, which is really good news.
That's really good. Oh, this is all really good news.
Yeah. So I told you I had some animal stories today. So
Yeah, I remember you saying at the beginning you had like a lot of animal stories.
yeah, so that's just awesome good news on the animal front.
Yeah, well, that's good. Converting things into things to save seahorses. That's fantastic.
Now that the Segway student has become the Segway master, over to you.
Yeah, so your story was about converting things into hotels. Mine is about converting trash to valuable graphene.
Oh, okay.
So you know what graphene is? It's a one atom thick layer of carbon atoms in a honeycomb structure, and under certain pressures, it's one of the strongest material in the world. Although it's extremely brittle, so if you twist it, it kind of snaps. But under pressure, it is an incredibly strong material. So the scientist has been testing different ways of converting carbon into graphene, because the way you do it is you heat it very quickly. So you very rapidly heat it and then remove the heat source. And this pulse of heat causes the carbon atoms to rearrange into that honeycomb structure. They were sort of playing around with the idea of doing it via electricity. And so they put a couple of screws through this black carbon, is what they call it, which is what's left over after a bonfire when you've burnt certain types of wood. So it's very, very dark powder. And just putting a tiny bolt of electricity through that, it vaporized basically all of the non-carbon in there, and all of the carbon rearranged into small sheets of graphene, which separate incredibly easily in water and a simple surfactant. A surfactant is something that helps materials mix with water more easily. And it still needs scaling up, but this might be a way of producing carbon on the large scale. And it works with practically anything. So he tried it with coffee grounds, and you can generate carbon out of coffee grounds. And coffee grounds are about 40% carbon. So that's pretty good. Like, if you think about all the coffee grounds that are thrown away every year, we could convert all of that into graphene. We could convert 40% of it into graphene and then capture the vapor to do something else with, perhaps.
That is really cool. Yeah, because graphene's one of those wonder materials that they think could have hundreds, thousands of applications going forward, don't they? Yeah.
Yeah, the main issue is cost at the moment, because it's about $200,000 for a single ton of graphene. So, and we need to be able to produce it in much bigger quantities and much more cheaply if we're going to do it in a way that's environmentally friendly and is actually useful to us. But yeah, so that's my story. And you could use it on plastic waste as well, because plastics are hydrocarbons. You know, once plastics begin to break down, if you keep them in storage for long enough to do that, or you can accelerate the breakdown process of them, you could rearrange them into graphene. It's just a case now of finding a way to scale up this process, but it's simple enough that should be possible. So yeah, that's my graphene story. Oh, cool. That's a perfect segue. That's a much better segue than my segue of converting stuff.
In the US, they were looking at manipulating electrons, and they basically think they've discovered a new form of matter. We're able to make the electrons line up into a sheet, into a kind of stable, stationary pattern. And obviously electrons aren't meant to do that. They're meant to be energetic, and they're meant to repel each other, they're meant to fly all around. But yeah, from certain angles, the electrons kind of formed a geometrically periodic, like perfectly repeatable array of pure electron puddles that resides between the layers of the... they were actually experimenting with two other ultra-thin materials, which I'm going to get wrong now, bismuth selenide and transition metal diachalcogenide. Probably said that wrong.
I think I've heard of the second one. I don't know the first.
But yeah, they thought it was a mistake at first, but they've been able to recreate it. Yeah, they've basically created kind of 2D pure electron lattices, which is the implications. It's very early days, and yet they think this could be really exciting for use in electronics, for sensing and information processing, and everything. But it's just they're kind of at the stage of like, how on earth is this? Does this work? What on earth is going on? It's really incredible.
So is it the electron structure which is the thing that marks this as a new material, a new form of matter?
Yeah, well, it's that the electrons all kind of, because they all kind of come together in a way that electrons shouldn't. You know, electrons should be kind of pure electricity and flowing and everything. But because it separates between those two ultra thin materials I mentioned beforehand, and it becomes its own kind of they use the word electric puddle, but it's basically like imagine just a kind of grid of pure electricity that just kind of floats between or exists between the two ultra thin materials, and it's stable. So they think it's a new form of they think it could be a new form of matter, because electricity doesn't behave like that. So even though it's made up of electrons, they shouldn't behave like that. So like, is this have we created kind of like electron 2.0 or something like that? I think they're still kind of looking at it.
They must be creating some kind of interference pattern, I would have thought, between the two plates. If I'm imagining this right, the puddles are forming between the plates.
That's right. Yeah, that's my understanding of it.
Right.
Yeah.
Yeah. So yeah, that's quite interesting. Like sort of two magnets essentially, but with a middle bit where the electricity all clumps together. The excitement of the electric field all happens in one place.
Yeah. I think kind of instead of magnets, it's these. Kind of materials similar to graphene in that they're ultra thin and they have unusual properties.
Are they conducting electricity across these materials, or
they fired beams of electrons through the materials, and then the electrons interfere with each other, as you said, and create a pattern?
Okay, now I'm with you. So I must have misheard that bit.
No, I don't think I mentioned that beforehand. But yeah, that's how. Sorry, I just said they were kind of experimenting with these ultra thin materials. But one of the things they tried passing current through it, and then they started shooting electrons through it, and the interference kind of created this pattern. So he said, I love the main researcher said, have you ever walked into a meadow and seen an apple tree with mangoes hanging from it? That's what they thought when they saw it. Like, this is wrong. This shouldn't be happening.
Do they know what are the next steps for this research? Like, where's it going from here?
I think they want to get other people to try and repeat the experiment elsewhere. Will be the main thing, and just check that they haven't made a mistake, because they are still a little bit. It was such an unusual result. So try and get that, and then start looking at potential applications for it. So I think they just want to test the effects further and see, as I said, that they might be able to use it for sensors or for information processing and things like that. So they're just going to test it out and see what kind of properties it has and how they might be able to use those practically going forward. Wow,
that's really cool. Are the two ultra thin materials also new-ish, or have we known about both of them for a while, and it's just a case of combining those two has created this interesting effect?
I think they are fairly new. It doesn't actually go into much detail here. I think it's just they were studying the properties of these materials, as you said with your graphene story. We know they have unusual effects, especially at the quantum level, potentially. So they were just trying them out, seeing what they could. It actually doesn't say what they were originally trying to figure out. They were just kind of studying electric charge and the way... That
suggests they didn't find it, doesn't it?
I think they were just testing, the various electric conductive properties of these ultra-thin materials, because trying to create new conductors and things is something that we're always trying to do to make better batteries and better, faster electronics and more efficient computers and things like that.
Yeah, wow. That's really cool.
So have you got any more stories for us?
No, I think that's all my stories that I've got today. So I suppose we should probably do the outro, unless you have a story you want to share.
Good few stories there, so I think I'll stop there. So happy for you to go ahead and take us out.
Thank you very much for listening. Please subscribe to the show to never miss an episode, and rate and review us wherever you have the power to do so. If you'd like to get in touch, we are at Not a Buffalo Pod on Twitter, Not a Buffalo Podcast on Facebook, or contact us through the website notabuffalo.wordpress.com. Bye.
Bye, everyone.